Pleasure to introduce Marcy Reed, who's the Chief of Business Operations with National Grid. National Grid is a massive energy company internationally. Marcy was former president of National Grid as well, and has been riding deeply in this journey from beginning to end as well. Marcy Reed and Debbie New from Mathers Out Front will be joining the stage now to really take us into the world of how they've defined the purpose of the study that's been undertaken and how they've found this common ground to move forward together.
Okay, that's fine. That's fine. Hello, everyone. It's so great to be here. I'm thrilled. So far for me, the highlight, in addition to hearing from everyone, was the picture of Bill Akeley doing the Saturday Night Fever thing. I loved that, Bill. It was great. It's a great one. But truly, I am so thrilled to be here representing National Grid, and the job that I have today, along with Debbie, is to talk about the innovative study and pilot that we've done together that Bill and Audrey and Zainab and Steve have talked about. But for starters, what I want to do is step back to a cold December day last December when, honestly, I was just sitting there probably watching a Patriots game, and the Twitter feed came alive. And some folks with me in the audience, we were texting back and forth, do you see this? This is interesting. Mothers Out Front were calling National Grid out by name, and they were dressed in large orange suits, depicting gas leaks, and they caught our attention. And so we tweeted back, inviting them to come in and talk about this. We'd love to hear their perspective, and could we get together? And so they did. They came in. The better tweet was after we met. We tweeted a picture of ourselves, didn't we? Anyway, they came in, and we met Debbie and Audrey and many others, and we decided right in the first minute that we did all want the same thing, believe it or not, and we were looking for a tangible benefit for our customers and indeed the environment. Margaret told you earlier that half the emissions from the gas system, particularly ours, which is the second oldest in the United States behind Baltimore, 7% of the emissions, 7% of the leaks produce half of the emissions. And the pilot that we talked about, maybe thinking about, was to identify those largest volume leaks and create a plan to fix them. And so here we were, a far cry from that cold day in December 10 months earlier. So we wanted to do solutions together. We were all energized about it. Very cool thing. At the end of the day, utilities exist for and are compensated by all of you, customers, under the regulation of the Department of Public Utilities to bring energy to your life in the most efficient way possible. That's the way the regulation works. But we also have a deep concern over the environment. And so long before we met Audrey and Debbie and others, we had actually submitted a plan to the Department of Public Utilities that would allow us, once it was approved, to go after our biggest leaks, our biggest grade 3 leaks that Steve so nicely described and explained for us, to get at the biggest ones first. And so when we got together, the question was around, can we study anything to improve that process, to get at to really improve how we were going to do that more quickly than maybe we thought. So we agreed in our case, and Steve and Bill have done the same thing. We identified some gas crews, good hard work and National Grid employees, and we sent them out to, in partnership with HEET and the representatives from Mothers Out Front, to do the pilot, to test leak identification, to test the measurement of all of it, and could we learn how to get at this problem more quickly than probably before we thought. There's tons to do. There's lots to do, but we are ready. We are committed. We're ready to take it on. And Debbie is going to tell us her perspective of this from the mother side.
One purpose of our study was to be able to make recommendations to the Department of Public Utilities together for new regulations addressing environmentally significant leaks. We often come at the legislature and the DPU from opposite sides, not to mention how we come at many energy and environmental issues. What a relief, we thought, for these decision makers who have been caught in the middle, for us to figure things out together and share our unified ideas for what we've shown will work and what will benefit us all. So our initial question that we brought to the utilities, and one that I asked Marcy, it was only in January, was, can we study the problem together, find solutions that work for everyone, and present those to the DPU? We knew that we can cut methane emissions in half from gas leaks if we can actually find the highest emitters. We also knew that utilities aren't allowed to pay for research in Massachusetts. And we environmentalists don't have jackhammers and aren't very good at using them. In other words, we know that no one of us could accomplish this without the others.
Great. So I want to re-welcome Audrey to the stage, who will guide us into the next part of our dance floor action.
Okay. So I am about to talk about how we did the study. And I want you all to be cognizant of the fact that this audience is filled of PhD students from MIT and utility experts and dentists. Like, it's a wide range. So please excuse me if I don't address you in particular. And if you have questions afterward, just ask anybody on the team. We're happy to talk. And a peer-reviewed paper hopefully will follow with a lot more science. So once the law passed that these leaks of environmental significance must be repaired, we had a problem, because with over 16,000 leaks across the state, no one had ever come up with an easy, reliable, fast method of distinguishing which of these leaks were large volume. The chamber method that Margaret used in her study would not work because it would take way, way too long. So the Department of Public Utilities selected the bar hole method, which is a simple method in which you bang a hole in the ground, insert the nozzle of a combustible gas indicator to read the percent of gas in the ground. If it's over 50% for 2 years in a row, that would be considered a large volume leak. The problem is that no one had ever tested if this method would be a reliable method to find the large volume leaks. So the goal of our study was, first off, test the method. If it worked, fantastic. If it didn't, we had to find some other method to find those large volume leaks. And remember, the potential prize here was big. There's, clearly a wide range of assumptions and information, and the time frame of the methane impact that can go into this. But the emissions equivalent is somewhere between 2 and 6% of the state's greenhouse gas emission inventory if we manage to fix all of these large volume leaks. That's basically the equivalent of turning off or decreasing the emissions from our stores and businesses by half. So it's a large amount. We also, because Massachusetts is ahead on this issue, we have a chance of making a national model for this. So before I start about the study, let me say that when you stand on the sidewalk and you smell gas, most people make the assumption that it's one hole in one pipe. That's not necessarily true. Because neighborhoods are built of the same materials at the same time, they tend to be, leak-prone infrastructure will congregate. So because of this, we try to think of the leaks as leak locations instead of a leak, because a leak, you always think one hole in one pipe. And it reminds me of the way my mom would always talk about the mouse in her kitchen for years. She had the mouse in the kitchen. And I wanted to say, where there's one mouse. So anyway, These are the leaks we studied. The utilities gave us 69 leaks as selected by the bar hole method. We researchers additionally put into the pile 14 leaks that were selected by the Picaro. I'll explain what that is in a minute. These leaks were on every type of pipe material that's leak prone, from cast iron to bare steel, etc. They covered a wide gamut of operating pressures. The pipes have different operating pressures, everything from ½ pound per square inch pressure all the way up to 99 pounds per square inch. The methods we used are basically, we studied these 83 total leaks in every way we could think of, and then we compared the leak rate in 3 different ways. Once we knew which leaks were the largest volume, we looked for the characteristics that would easily identify those leaks. So pay attention, because at the end you all get to vote on which methods you think were most successful, okay? And the success is determined as by being reliable and easiest. So first we studied the leaks the way the utilities do.
For every leak in our study, we performed a leak survey. We located the leak using gas detection equipment. Once the leak was located, the FI, or flame ionization unit, determined how far the gas had traveled. We measured the width and the length of this gas-saturated surface area. This is called the leak extent, or footprint. Bar hole reads were also made whenever possible.
Next, we also did this.
We also drove by each leak with a Picaro, a high-precision natural gas analyzer. This device has an intake tube in the front of the car. The Picaro analyzes the air to measure the parts per million of methane, while it maps its location with GPS. The data that results produce maps like these. In order to reduce the effect of the wind and other factors, we drove by each leak at a steady speed multiple times. We located the largest peaks using an algorithm called area under the curve. This is a numerical way to compare the size of different peaks. We wanted to find out if the Picaro could select high-volume leaks.
Okay, and then we compared the leak rate in 3 different ways. First way is...
Every leak in our study was measured using the chamber method. This was the same method used in the Hendrix study. The chamber was placed on every spot with measurable gas escaping. We recorded how quickly the gas built up inside the chamber over time. This was done in order to calculate the flux, or rate of emissions. One leak was so large, we had to make 170 separate chamber placements. The chamber method has been scientifically verified and peer-reviewed. Though considered to be the gold standard of gas measurement, it is extremely laborious. In order to verify each of the other methods of measuring gas, we compared its results to the chamber method data.
So that's the first method. That's the reference method. These are the methods we were testing.
I'm Alan Waxman. I am the founder and chief scientist of Multisensor Scientific. We've built an infrared camera that operates in a part of the infrared spectrum that we call the shortwave infrared. So we're actually looking at reflected sunlight. We're not looking at a heat signature at all. The information is relayed to a user interface on a small commercial tablet.
What I'm particularly excited about is that I see this technology and this product as a win-win-win situation. It's going to help utilities to be more productive, to find leaks faster, to get better quality of data. At the same time, we're going to help the environment to reduce methane emissions.
The camera was only used on national grid leaks, and it's a passive method. This next method I'm going to show you is, the video is a little bit longer because it was invented by the entire coalition, and so it's a beautiful demonstration of what we can all do together. We needed a device to tell us which were the biggest leaks. With a tool like that, utilities could learn how to save the most emissions for the least cost. This is the story of the flux bar. We started off by consulting experts. Luckily, Dan Cody from NiSource began helping us. NiSource is the parent company of Columbia Gas.
First, it had to be a simple process. The equipment had to be rugged. It had to be easy to use. It also had to fit in with the typical flow of a leak repair. It couldn't be disruptive to the crew to get the work done. And at the same time, it had to be as accurate as we could reasonably make it.
Our first designs were very primitive. When we showed this design at a meeting with Eversource, there was this really long silence. Then Kevin Kelly of Eversource suggested we consider the purger instead. It's a utility tool that vacuums gas out from under a street so a leak can be located. If the purger were modified, it might work. So we organized an MIT hackathon to improve it. With input from the hackathon, we approached Brian Ferry of Millibar, the local manufacturer of the purger. He created a prototype that we tested to ensure its accuracy.
Within just 2 months, Millibar had produced the first flux bar. It was tested out for the first time in Springfield with 3 utilities watching. The flux bar works by being inserted into a hole drilled right over the leak. It gently vacuums air out of the ground at a consistent 3 cubic feet per minute. By connecting a gas detection device, we can measure the percent of gas in that consistent airflow. Once the built-up gas under the street is drawn off, the result allows us to measure the leak rate.
That will give us much better insight into not just environmental risks, but also public safety risks that are a core obligation we have as gas operators.
The flux bar can't be used, just to explain, for identification of leaks because it needs a compressor truck in order to work, but it's really easy to use when you're actually just before you repair the leaks. So it's good at verifying the leaks. So those were the 3 ways we used to, check the leak rate. Zainab's going to tell you about after the break about what methods actually worked, but I thought you'd all get, it would be great to have you all vote for a second. Who thinks the bar hole method would be the method, would work to be the easiest and most reliable? Show of hands. Okay. How about leak footprint? Okay. How about the Picaro? Yeah, we got some Picaro. How about the flux bar, number 4? Maybe more flux bar. How about the MSS camera? A lot of MSS camera. Okay, and it's all judged by the, as judged by the chamber method. So now you get to go and look at the technologies. They're up in the lobby. There's some coffee and cookies up there. Bathrooms are down here. Don't look for bathrooms upstairs. You'll get lost in the maze of MIT. You'll disappear. There's questions. If you have questions, write them down on cards. People should give them out up there, and we'll be back here at 11 o'clock. Thank you so much.